Hi everyone, welcome back to the Preformulation Study, Formulation and Pharmaceutical Science Perspective, Part 3. This online lecture on pharmaceutical science is sponsored by Gold Pharmacy under the philanthropic vision of quality education for all. Today's lecture we are going to discuss in detail about solid state characterization. As we know that most of the pharmaceutical product, more than 70% is under the solid state. So the solid state characterization play a very important role in formulation development. So solid state characterization is a key to understanding the physical properties of pharmaceutical solid materials and ensure the optimal physical forms. As I said, solid state characterization is important to understand the flowing properties of new drug entity or new chemical entity. Mostly, they are going to be morphology of the solids, substance or the particle size or a polymorphism, solvation, hydration. These are the parameters which going to influence the physical properties and ultimately the dosage forms. The dosage forms, solid dosage forms like we are having powders, granules, tablets, all these dosage forms, the physicochemical properties of the new chemical entity greatly influence the performance of the dosage form, like the dissolution, solubility, bioavailability of the drug or the new chemical entity. So, solid state characterization is play a very important role in formulation development of pre-formulation study or a formulation development of a stable dosage form. To characterize these solid dosage form, solid particles or new chemical entities, we are going to use many techniques to characterize the solid state. The most in brief is the first is the microscopic method where we are going to use the polarized light microscopic where we can determine the crystallinity or amorphous forms. Also, we can use scanning electron microscopy method where we call SEM, where we can morphologically characterize the solids such as crystal habit, glassiness, amorphous. Then the next method is infrared spectroscopy method, also we call FTIR spectroscopy or Fourier transform infrared microscopic method where we can analyze the solid in a molecular state or molecular structure can be identified or characterized. Similarly, the next method is thermal analysis. Under this thermal analysis, we have different methods, and one of the most prominent and commonly used method is the different scanning colorimetry method, or we call DSE, where the drug substance or new chemical entity, melting point, glass transition temperature, heat capacity, all is going to be analyzed by using DSE analysis study. Similarly, thermogravimetry analysis TGA, we are going to analyze the drug substance or new chemical entity, solid substance characterization under the desolvation or decomposition methods. Another method is called crystallographic method, where XRD or X-ray crystal or powder diffraction techniques will be used for this XRD equipment, and we are going to characterize the crystallinity and amorphous form where the fingerprint identification also can be carried out by using crystallographic methods. The other methods for solid state characterizations commonly used in manufacturing or development of a product is the bulk property characterization, where the density, flowability, compressibility, all these parameters going to be characterized. Similarly, the particle size analysis also play a very important pivotal role in making of a solid dosage form or making of a solid formulation. As I said, the characterization are different method, different techniques we use to do for physical characterization of the solid components or solid ingredients or the solid new chemical entity, but many methods are used. And here is this is the picture depict the different methods and how much quantity required to analyze the product. In case of the microscopic method, we need less than 1 mg or 1 mg, hot stage microscopic 1 milligram, then different scanning calorimetry or DSC 2 to 5 milligram, TGA or DTA thermal analysis or thermography analysis 2 to 5, and thermography gravimetric analysis 10 milligram, infrared spectroscopy 2 to 20 milligram, XRT 500 milligram, scanning electron microscopy method 2 milligram, and dissolution study sometime we need milligram to grams. So, as I said, the common techniques to understand the fine particle of the various components we can also use in other way like microscopic sieving or sedimentation, illustration, centrifugal or permeability or light scattering techniques can be used to analyze the particle size, and this is the how the particle size will be determined by microscopic method. The particle size could be 1 to 100 micrometers, sieve analysis more than 5, sedimentation more than 1 micrometers, illustrations like 1 to 50, centrifugal less than 50, permeability more than 1 micron, and light scattering zero point 0.5 to 50 micrometer size we can able to analyze the particle size of the component. As I said, the particle size is very important, and to understand the pliability and characterization of the uh, solid ingredients or the solid state materials is going to be carried out. This is one of the few example where we can use the particle size distribution profile by using zeta potential and zeta sizer we use to analyze the particle size, where we can able to find out the particle size distribution, and the average size of the particle is 106.3 size, and polydispersity index also able to get it the dispersibility, and the result is found to be characterized and using this photon correlation spectroscopy or zeta sizer we use. And similarly, zeta potential and particle size can be analyzed using a zeta sizer, and this is the example where a fabrication of a second generation smarter PLGA nanocrystal formulation development has published recently, and that work has highlighted that how the particle size is going to play a important role in manufacturing or formulation development of any dosage form. As I said, the particle size, shape, surface morphology is an important one. Here, this is the picture depict the morphology characterization by a field emission scanning electron microscopy FESEM images. Again, this is the paper published recently in 2019, and this work has uh, indicate that how the surface morphology after development has characterized and how it is going to influence the performance or bioavailability of the molecule is presented in this publication. Another method is polarized light microscopic method, PLM, is to be used to differentiate the crystals and amorphous solid components. Crystalline solids would appear a green prince image or shiny rainbow structures, and non-crystalline solid appears like a pitch black image that indicate the how we can differentiate amorphous form and crystallinity. As I said, the scanning electron microscope is commonly used for the morpholysis analysis. This ACM is used to observe the overall surface structure of the solid. Samples are coated and by heavy element gold or palladium coating. Over that, this your component will be spread over and bombarded with that electron under this vacuum so that it generates this electron, and that electrons going to be captured under the scanning electron microscopic method. This provides the information how the molecules, the surface structure going to be. The samples are should be non-recoverable and it's going to be commonly used to understand this. And this is the one example here. You can see that scanning electron microscopy of carbazepine polymorphic forms. Form 2 is a acicular, form 3 is a plate-like structure. And this is how differentiate by using scanning electron microscopy method. The another important we have discussed earlier is the FTIR, Fourier transform infrared spectroscopy or infrared spectroscopy is called fingerprint analysis of the drug substance or new chemical entity. So infrared spectroscopy technique, it measures the absorption of infrared light as a result of a bond vibration and stretching. It is used for drug identification and presence of the drug or drug excipient interaction, crystallinity, amorphous, what can be characterized, and mostly FTR spectra are usually in terms of web numbers they analyze, and this is the fingerprint structures going to be unique characterization for a individual molecule or components going to be. So this is also a very important parameters to characterize the molecular structure fingerprints level by using FDIR study. The next one is the thermal analysis. Most commonly we use DAC or TGA, and among them within that DAC is more popular in drug excipient or drug analysis or polymorphic forms analysis. DAC will be very commonly used. Let's have a discussion in detail about these two methods. This both comes under thermal analysis and useful for determination of purity, polymorphism, solvent, moisture content, stability, and compatibility with excipients. So how the drug components individually or drug excipient, how they compatible, we can analyze by using thermal analysis method, mostly DSC or TGA. It involves heating of the sample under a controlled condition and observing the physical and chemical changes in terms of DAC. In case of the DAC, there is a amount of the heat absorbed or released and the temperature changes will be analyzed. In case of TGA, thermogravimetric analysis, the weight change or gas evolve will be taken into account how get changed with presence by heating the process along with the drug or drug experience together. And this is the how going to characterize the solid components by using thermal analysis. So the difference scanning calorimetry DAC is a versatile technique and more precisely it can determine the enthalpy entropy taking into account each components when each molecular structural components can be identified. Then similarly the measure the small quantity is required in case of this analysis. Measure thermal properties as a function of the temperature and it can be used to determine presence of even impurities. So pure drug DAC thermograms and the mixture of the drug and the impurity will be run together in a DNC and we can differentiate the extra peaks or a reduce of the intensity of the peak entropy or enthalpy can be determined by using going through this different scanning calorimetry. So this melting point is the main important point for the drug substance or the chemical entities. Crystallization, this is how it's going to be, and the glass transition temperature of the component which represent the amorphous forms going to analyze in using this DSC study. Preliminarily, identification of the polymorphism can possibly and decomposition. If the component get decomposed, it's not going to be ideal one to this scanning DSC study. So this is the how we analyze the molecule where you can see that isotherms stretching, then starting the transitions, then glass transitions, then crystallization, then fusion, then transition. This is all the structural changes will be with temperature. These characteristics will be analyzed by using different scanning calorimetry or DSC. In case of thermogravimetric analysis, measures the amount and the rate of weight change of a material with respect to temperature, and measure small quantity of the samples can be used in this study also, can be paid to infrared or mass spectroscopy to elucidate the nature of the gas evolve and determines the decomposition and degradation temperature. It can possibly allow compared to DAC, this can be allowed to decomposition and degradation temperature is ideal. Desolvation of the solvents or hydrates, monohydrate, dihydrate, trihydrate can be analyzed by this thermogravimetric method of analysis. As I said here, you can oversee that the glass transitions, gas will be entered through oven, heater will be there, and the temperature will be allowed to form the gas, and those gas will come out, and that gas going to be analyzed. So that is how the decomposition process is going to determine in thermogravimetric analysis. Another crystallographic technique is commonly used for the crystal behavior of the components, solid components. So X-ray powder diffraction is a XRD, we call it XRD. X-ray are the form of electromagnetic radiation having a wavelength on order of a interatomic distance. When this X-ray will be work over in the electromagnetic radiation stage, the X-ray is diffracted by the electrons surrounding in the individual atoms in a crystal structure. And by this, what is the principle is going to be a diffraction pattern are resulted by bombardment of the X-ray and at a particular angle, this the diffraction of those atoms or in a crystal lattice will be result a unique pattern, and that is going to be determined or analyzed crystalline solid components. This provide a characteristic nature of a compounds by XRD analysis. This is how you can see compounds having a different polymorphism, and different polymorphic forms have a different characteristics of XRD thermograms, and these characteristics analyze, and this is how result differentiate the each polymorphic forms or drug excipients or even drug excipient incompatibility or compatibility can be analyzed by XRD diffraction technique. So this is the basic characterizations normally we use to do the study for solid state characterization. Different techniques are used and other parameters also going to be used in bulk characterization of the solids such as bulk properties of the powders. So this ball property is going to be a very important role in manufacturing of the tablets, capsules, or even granules. And this is the performance is going to play a very important role in the performance in the bioavailability or dissolution study or solubility. And a later stage, you can understand how it's going to be important for making of a stable, safe, effective delivery system or a drug formulation development. So powder flow property under the bulk property studies of the powders, the first characteristics is the powder flow properties. Flow characteristics is important when handling the drug powders because at a preformulation stage we are going to evaluate how the powder flow property based on two parameters. One is called bulk density analysis and another is the another angle of report. Mostly the factor affecting the flow properties of the powders is basically the particle size, shape, surface morphology, density, porosity, electrostatic charges going to influence the flow properties of the powders. And as you know that in manufacturing of the tablet or a capsule or any granulating formulations, if you are making any formulation, need a good flowability. So to get uniformity of the drugs need a good flowability. So we have to analyze before going to formulate into a tablet dosage form or a capsule or a granulation techniques when you use for the granulations. We have to understand what is the nature of the powder flow property. And basically, this flow property, as I said, we can analyze by using or study in detail about the ball density characterization or angle of repose study. So the ball density will be measured by two different ways, and this is going to analyze by understanding the apparent bulk density of a compound or substance, which is determined the bulk density is gram per cm cube, and the bulk drug powder is sieved through a protein screen. Particular weight is taken and poured into a graduated cylinder via a large funnel, and the bulk volume will be calculated. And finally, we calculate the apparent bulk density, weight of the powder divided by bulk volume. That's represent the apparent bulk density. Next parameter is the tap density, is gram per cm cube. The unit, the bulk powder is C through 40 mesh screen. Weight is taken and poured into a graduated cylinder. The cylinder is tapped 1000 times on a mechanical tap apparatus, and the volume reached to the minimum will be determined or observed will be noted, and that volume is called tapped volume after 1000 times of tapping of the component in a measuring cylinder. So the tap density is going to be weight of the powder divided by tap volume. So after determining apparent and bulk density and the tap density, we are going to use these two parameters in understanding the powder pliability. So United States Pharmacopoeia has clearly given a guidelines how to determine the tap density, bulk density, and this is what just a basic information to use that. So tap density or densitometer is equipment is available to determine the bulk density and tap density. This ball density is basically indicate the flowability of the powders, indication to see that is there any chance of segregation if the improper powder flowability there will be chances of segregation when we'll go for mixing of the powder of two different nature. So that's the reason we have to characterize the powder's flowability before going to formulate into a tablet or a capsule dosage form. And this can be also useful to understand the compressibility and compactability and flowability by using the ball density analysis study. In this case, the CATS index. The CATS index is a simple technique by which using a tap density and the ball density, we can measure the CATS index. And this is how it's going to be represented. Tap density minus pore density divided by tap density multiplied with 100, it's represent the percentage Cass index. Similarly, Hausner's ratio is the ratio where the tap density and pore density ratio will be determined as a Hausner's ratio. The very important part of this analysis is the Cass index. As I said, if you after doing this Cass index, if you find the nature of the substance comes under 5 to 15, then it's indicate a good compressibility or excellent flowability. Similarly, 12 to 16 represent good, and 18 to 21 is fair or passable, and 23 to 35 is a poor flowability, and 33 to 38 represent very poor, and more than 40 Cass index is extremely poor. So in this case, we have to analyze. After doing that, we have to do some modification or some other technique by which we can improve the flowability, because if the flowability is not taken care, then you will find weight variation and doses in the doses assay variations in the later stage of the formulation. So this is a very important parameter we have to take into account in formulation development, and that's the reason most of the time pre-formulation study, this is the most important part of analysis of pre-formulation study. Similarly, Hausner's ratio, we are going to be determined less than 1.5 1.25 is represent a good flowability. 1.25 to 1.5 added with glidant. The flowability is can be improved by addition of a glidant, and more than 1.5 represent poor flowability. So this is how we have to understand analyze after doing this analysis, bulk density analysis. We have after analysis of those new chemical entity or the your drug formulations development excipient together with the drug or new chemical entity, we have to understand how to improve and what is the nature of this combination or the drug itself, and in combination with the excipient, how they behave, the flowability. So this bulk density characterization is a very important in analysis and understanding of the formulation development process. Another parameter where we can understand the flowability is the angle of repose. This is when a gravity is applied, and so that the components will get a static heap of the powder and it will tend to form a conical mount. So the angle to horizontal plane is determined, and that called the angle of repose, which cannot be exceed a certain value, because after certain period, a certain angle, the due to the gravitational force, the components start sliding and going to form a particular uh, a unique angle for a particular mixture or a powder components. So here the angle of spatula sometimes is a small quantity we can use, but this is how it is characterized, that if the angle of repose is less than 20, is represent an excellent flowability. 20 to 30, good. And 30 to 34 is considered to be passable. And more than 40 represent very poor flowability. So this is also another way of understanding this, the component, how it's going to influence the flowability, and taking into this account, we have to modify our formulations or the composition or the excipients, so that a better flowability, better dosage form, better weight variations can, those weight variation can be minimized, or the assay uniformity or drug content uniformity can be improved or rectified by taking into consideration of bulk density and angle of repose studies in pre-formulation analysis. The next one is the hygroscopicity. Many pharmaceutical materials have a tendency to absorb the atmospheric moisture, especially water or soluble salt forms. They are called hygroscopic materials, and this phenomenon known as hygroscopicity. Equilibrium moisture content depend upon the atmospheric humidity, temperature, surface area, and the exposure time and mechanism of the moisture uptake. Deliquescent materials, the can absorb they can absorb the sufficient amount of the moisture and dissolve completely in it. Example, anhydrous calcium chloride, which can use which can absorb the atmospheric moisture. The amount of the moisture absorbed can be determined by following methods like gravimetric methods, thermogravimetric analysis or TGA, Carl Fisher moisture analysis, you know, as we very commonly use KF analysis, Carl Fisher moisture analysis, or gas chromatographic techniques. So these are the most common techniques used in industrial way to understand the how much moisture will be permitted and how much moisture is the components along with the drug or drug excipients together can absorb is going to determine, because moisture also play a very important role in formulation development. As we know that hygroscopicity is going to the inherent nature of the drug components. Sometimes because of that, most of the time drug leads to a instability. Sometimes the too much non-hygroscopic, then the formulation is not going to work in the dissolution is going not to be formulated of the developed formulations, or solubility will be hampered. So certain percentage of the moisture also required in making of a tablet, as we know that 1 to 2% moisture is required. So to understand the moisture content in a formulation is very important. So to do that, we are having different techniques And those techniques can be implemented in analysis of the moisture content in the formulations or in the mixture of the formulations or in formulations of the drug along with the excipient in a pre-formulation study to develop a stable dosage form. So, as I said, the hygroscopic substance has play a very important role because most of the component, any component along with a drug or excipient can be characterized in a hygroscopic substance into different class. This could be class 1, class 2, class 3, class 4. So the class 1 hygroscopicity classification based on that, essentially no moisture increase occurs at relative humidity below 90%. Means no moisture going to adhere occurs relatively low moisture at humidity below 90, then that class of the components can be considered as a non-hygroscopic. Then class 2 is considered to be slightly hygroscopic when essentially no moisture increase at relative humidity below 80. So below 80, if it is not increased, then we call it as a slightly hygroscopic. Moderately hygroscopic or class 3 is the moisture contents does not increase more than 5% after storage for a 1 week at a relative humidity below 60, then we consider it is a moderately hygroscopic nature. Similarly, class 4 is considered to be very hygroscopic if the moisture content increase may occur at relative humidity as low as 40 to 50, but still it is absorbed a lot of moisture, then we consider it is a very hygroscopic. So this is a very brief informations about different techniques and these methods. And this is what we want to highlight that in a pre-formulation study, these are the parameters has going to characterize so that we can able to develop a stable, suitable formulation which take further into development of a formulation development and into further develop a dosage form. So thank you very much for your attention. Hopefully we will be meet in the next lecture. The next lecture will be the last lecture and the final lecture of pre-formulation study. See you in my next lecture. Thank you very much for your attention. If you would like this video and to encourage us, please like and share and this type of the educational videos to see in the future. Please give your like and share. And if you have any queries or any questions, you can put your discussion in the discussion group of the YouTube presentations. And you are most welcome. Any queries, any things you have, even you can personally you can mail me to vivuprashad25yahoo.co.in and see you in my next lecture. That will be the last and final lecture of pre-formulation part 4, and see you in the next lecture. Thank you very much for your once again for your support and encouragement.